Hi everyone, this is Mrs. Leong, and this is lesson 1.5, Solving Inequalities. All right, so we're going to be talking about solving some inequalities, and here are some properties. We have addition, subtraction, multiplication, and division. It works pretty much the same as equations, where you can add and subtract, multiply and divide everything on both sides. Now, the only key difference here, and I've highlighted and starred it in bold, is that when multiplying or dividing an inequality by a negative number, you need to make sure you reverse the symbol. So if it's greater than, you're going to flip to less than. If it's like less than or equal to, you're going to flip that to greater than or equal to. All right, so let me show you a few examples here. Number one, we have solve each inequality, then graph the solution set on a number line. All right, so here to isolate m, I'm going to go ahead and add 8 on both sides, and then that gets me m is greater than -4. Notice here I didn't multiply or divide by a negative number, so I didn't need to flip the sign. So that is my final answer, and then my number line is going to be an open circle on -4 going to the right. All right, so these are all my numbers that would fit into this inequality. All right, it's open because there isn't an equal sign. All right, let's try the next one. All right, next one, number 2 we have is, I'm going to add 15 on both sides. So that gets me this, divide 4 on both sides, and that gets me this. So this one, I'm going to go ahead and have a closed circle on 9 and shade to the left. Okay, and that's all you need to graph that number set. All right, number 3, I have variables on both sides. Again, just like an equation, I'm going to get all my variables to the left. So I'm going to go ahead and subtract 4x and add 6. That gets me this. And then I'm going to divide by -14 here to isolate x. So because I'm dividing by a negative number, I need to flip that sign. So then here is my solution, and here is my graph. All right, and my last one, I have a fraction here. To get rid of that, I'm going to multiply both sides by 8, multiplying by a positive number, so I do not need to flip the sign. And that gets me here. And now I'm going to add 3 on both sides, and then divide by -5. Don't forget to flip that sign when you divide by -5, and then graph that solution set on a number line. All right, so that is a quick reminder of how to solve inequalities. Okay, number 5, we have a word problem. It says, Craig is delivering boxes of paper to each floor of an office building. Each box weighs 64 pounds and Craig weighs 160. If the maximum capacity of the elevator is 2,000 pounds, how many boxes can Craig safely take on each elevator trip? All right, so when I have a word problem, I like to go ahead and set up what my variable is. So I'm going to let x be equal to the number of boxes. Each box weighs 64 pounds. So 64 times the number of boxes is going to be how much the boxes weigh in total, plus Craig himself, and I need that to be less than or equal to 2,000 pounds. The reason why I'm using less than is because it doesn't have to be exactly 2,000 pounds for that elevator work. It'll work as long as it's 2,000 or less pounds. So let's solve for that. Subtract the 160 and divide the 64. And I get x is less than or equal to 28.75. I'm assuming I can't take a fraction of a box, so my maximum is going to be 28 boxes. When I write my answer, though, I need to specify that Craig doesn't have to take exactly 28 boxes, though. He can take at most 28 boxes, or 28 boxes or less. So in words, I'll say Craig can take 28 boxes or less. Okay, make sure you don't say just 28 boxes, because again, he can take less than that. Okay, let's try the back, number 6. The directions say define a variable, write an inequality, and then solve. All right, so 3 parts to this. So we're going to go ahead and set up my variable, let x, in this case it says the quotient of the sum of 3 and a number and 6 is less than -2. So we're looking for what a number is. All right, and let's set this up. The quotient of, so I'm going to have a division sign, of 2 things, the sum of 3 and a number, and 6. All right, so those are 2 things I'm going to divide. The sum of 3 and a number, and 6. And that is less than, so is less than, is that inequality? -2. All right, so that is my inequality. I'm going to multiply both sides by 6, and that gets me here. Subtract 3, and that gets me here. All right, so I solved the inequality. So I'm going to say the number is less than -15. And rule of thumb, I would say if it's a word problem, typically you want to answer in words. Okay. All right, and then number 7, it says a third of the sum of 5 times a number, so that's what I'm looking for again. So I'm going to let x equal to a number, defining the variable. 1/3 of the sum of 5 times a number, all right, so I'm taking 5 times a number and 3, adding those two things, is less than, all right, so that inequality once again, 1/4 the sum, so I'm going to add two things together again, the sum of 6 times that number and 5, so 6x plus 5. All right, so that's how I would translate that. Okay, let's go ahead and solve. I'm going to multiply both sides by 12, essentially, to get rid of those fractions. So that leaves me with 4 times that quantity, and then 3 times that quantity. Okay, so I get 20x plus 12 less than 18x plus 15. Subtract the 18x, subtract the 12, and x is less than 3/2. All right, so the number is less than 3/2. And I do like improper fractions more, so just leave it like that. Don't turn it into a mixed number. All right, hopefully that helped, and use the homework problems to practice on your own.